Welcome to Whiteboard Programming, where we simplify programming with easy to understand whiteboard videos, and today I'll be sharing with you what is hashing in blockchain, its importance and how it works. So let's get started. Fundamentally, hashing is the process of taking input string of arbitrary length and turning it into cryptographic fixed length output. And just to remind you that hashing is not encryption, both are different, and we can't retrieve the original data by decrypting the hash. It's a one-way cryptographic function. And if we take the example of blockchain used in cryptocurrencies, transactions of varying length are running through a given hashing algorithm. And here all are given an output that is of fixed length. And do note that this output string is independent of the length of input data which we fetch into it. The output which we receive is what we call as a hash. A good example of this is Bitcoin's secure hashing algorithm 256, also called as SHA-256 algorithm. Hashing done using SHA-256 gives an output resulting of fixed length, which is a 256 bits length, and generally the output size is of 32 bytes. So this is the case whether the transaction is just a single word or a complex transaction with huge amounts of data. And always remember that the size of the hash will depend on the hash function's utilization. But the output of the hash using a particular hashing algorithm will be of specific size. That means hash value of Learn with Whiteboard and Branalytic would both be of equal length no matter how much is the size of the input data. And just as we discussed, the process of using a given hash function to process a transaction is called hashing, and cryptography plays a major role at the heart of it. Some of the characteristics of these cryptographic hash functions include the following. Number 1. Deterministic. That is, it will always give you a fixed value output. Number 2. Quick computation. That is, it may be difficult to find input data for a hash function, but computing or calculating the hash is ideally very fast. Number 3. Pre-image resistance. That is, given a hash of a particular transaction, it should be virtually impossible or practically infeasible to determine the original input data using the output. And this property of hashing is something that lends a good level of security to the blockchain. Number 4. Randomized. That is, hash functions produce different outputs to every input, even if the input data differs by only a digit or a letter. For example, hash of the given word apple should be completely different from the hash of the word apple 1. Number 5. Collision resistance. So, if a hash function gives same value for two or more unique inputs, it is called collision. And cryptographic hash functions are supposed to have collision resistant properties. That is, they should never have the same output for two or more unique inputs. Now, as we understood the fundamental of hashing, let's take a deep dive into how hashing in blockchain works. As we all know that blockchain is a sequence of blocks. Each block in it contains data and a hash pointer that points to its previous block, hence making the blockchain. This hash pointer contains the hash of all the data inside the previous block. And believe me or not, this tiny feature is what makes blockchain so popular and revolutionary. And here, if a hacker attacks block 3 and tries to change the data, due to the property of hash functions, even a slight change in the data changes the hash drastically. This means that any change made in block 3 will change the hash stored in block 2. This in turn will change the data and the hash of block 2, which results in changes in block 1 and so on. This contributes to what exactly we call immutability in blockchain. That is, any tiny change in the data are immediately noticed and nullified by each preceding block, and this is how essentially the concept of hashing plays a role in blockchain. Next, let's talk about blockchain and hashing. So, here are some of the individual use cases where hashing in blockchain is employed. First, addresses on the blockchain are derived from hashing. For example, Bitcoin addresses use SHA-256 and RIPE-MD160. Next, hashing helps in defining cryptographic signatures that help determine a valid transaction. Next, the hash of a transaction makes it easy to keep a track of transactions on the blockchain. Instead of looking for a transaction that was 150th in the block 2053, it's a lot easier to just copy the hash into the Blockchain Explorer from where you can view the transaction details. Next, hashing functions are crucial in crypto mining, where a valid nonce is discovered by computing several hashes, and this helps to form a consensus on the blockchain. Next, the use of hash of the data helps in storing large amount of data on the blockchain. Further, as this is time-stamped and can be hashed for future reference as well, it makes permanent data storage less bulky or simply more economical. Next, hash rate is a feature which allows us to determine how fast and smoothly running the mining process is, and it is also vital in determining difficulty levels during mining. Lastly, as a conclusion, I'd like to say that the cryptographic hash functions is an integral part of blockchain innovation, and it is essentially a feature that gives security capabilities to the processed transactions, making them immutable. Further, hashing also plays an important role at the center of Merkle trees, which is quite useful in the issues of scalability and creating mobile light wallets. But we'll talk about that some other day. With that, I hope this video was helpful to you and served value. If you love my content, feel free to smash that like button, and if you haven't already subscribed to the channel, please do, as it keeps me motivated and helps me create more content like this for you.